Welcome to the next video. In this video, I want to show you how you can time your Python code so you can evaluate how much time does the execution of a certain Python code takes. Okay, I'm here now on the official documentation of the timeit module from the Python standard library. And with the timeit module, you can just code slices of Python code, and you can see how much time did it take. If you scroll down a bit, you would see here the Python interface part, and we can create here a timeit variable that will execute, or it will create a timer object, and there the execution of the Python code could be done. Also, if you scroll down a bit more here, we could go to the timer class. So this is the main class of the timeit module. And if we create an instance of this class, we can afterwards time, for example, 1 million executions of the code line, for example, and then we would get the time for executing 1 million times the passed in code. If we want to compute, for example, the mean time of, let's say, 10 executions, we could use the repeat function. So per default, the repeat parameter here would say, okay, we execute the Python code 5 times. So this repeat function would return a list of 5 times. So for example, 1 second, 1.1 seconds, 0.9 seconds, again 1 second, and for example 1.2 seconds. And then we could compute the mean time over these 5 time durations. So the mean duration we could compute. And this I will show you right now. So I have prepared here our code in the timing directory, and I have added here some Python strings to say which Python code we want to execute or we want to time. And the maybe odd thing here is we have to state the Python code that we want to time in this triple quotation mark strings. Because if we now create an instance of the timer class from the timeit module, we pass in these strings. So the timer class would under the hood create a new Python instance. So it would start a new Python execution on your computer and would then paste in this code here, and it treats this string here as valid Python code, or it should be a valid Python code. So under the hood, a new Python instance is created, and the code that we are defining here in the triple quotation mark strings is executed. So sometimes we want to execute some, for example, functions from modules that we need to import first. Because of that, the timer class has a parameter that is called setup, and there we can pass in, again, a triple quotation mark string where we define our imports, for example. So everything that we want to set up, which is in our case, for example, imports, or if you want to set the seed of something, you can do this preliminary work in the setup part. So I call this value here import string, for example. You can pass it here for the setup parameter. The code that you want to time then is passed in here as a first parameter. So for example, here I create 2 vector instances with random values, and I want to just add these 2 vectors to create a third vector instance. So the code is pretty much the same as we saw in the debugging video. And the important thing here is that the triple quotation mark strings are white space sensitive, so to say. So if you now would tap here our code, so let's say for example this here, we would see that here an indentation is already carried out. So the strings have to start at the first column of your code file, even though the variable that we want to store here doesn't start at the first column. So it's a bit I would say ugly to define these strings here, but you have to do it like this, because otherwise the Python interpreter that is started under the hood by the timer class would also count these spaces here into the Python execution. I could just run it for now, and here we would see, and that I wanted to just elaborate here, we get an indentation error, unexpected indent. So you just have to define these triple quotation mark strings starting at the first column of your code file. If I would run it right now, I wouldn't get this indentation error exception here. Okay, so I have created here an object of this timer class right now. And here the first parameter is the statement, so the Python code that should be executed. And as I said, if you have to import something, or if you have some setup steps that have to be carried out before you can really run the statement part here, you can pass this as a string here for the setup parameter. Okay, next we could now run either this timeIt method. So in the timeIt method, with the parameter number, we would execute the Python code that we passed in here in the statement string, for example, 1 million times. If you do not want to execute it 1 million times, you can obviously change the value here for this parameter. For example, if you only want to execute it 10 times, you would just pass in here 10 as an argument. Okay, this would result then in 1 time that is returned here. So if I read the documentation here, time number executions of the main statement. This executes the setup statement once. Important, the setup statement is executed once, and then returns the time it takes to execute the main statement a number of times. So if we want to add our vectors for 1 million times, the setup, so the imports, are executed once, and our statement is executed 1 million times, for example. And then the time is returned for executing the 1 million executions of the statement. So if you just want to execute it one time, I have to pass in 1 as an argument here for the number parameter. Then I would get the time of executing the statement once. The argument is a number of times through the loop. So under the hood, it is just a for loop that executes our statement number times. Okay, then next, the main statement, the setup statement, and the timer function to be used are passed to the constructor. So if you have any special needs of the timer function, you could choose it here in the constructor of the timer object. But for now, I will just take the default timer that will return our timing in seconds, for example. Okay, next, the other important method here is a repeat method. Here we can pass in the number of repeats and this number parameter. This number parameter here is exactly the same as the number parameter here of the timeIt method, because under the hood, the repeat method will call the timeIt method repeat times. So if I set repeat to 5, it would call our timeIt method 5 times. And here at the repeat method, we would then get a list of 5 time durations that the timeIt method took. So as I said before, so I can do a little draw here. So if our timeIt method returns, for example, 1 second, 1.2 seconds, 1.1 seconds, 1.3 seconds, and 0.9 seconds, for example. So we have right now 5 executions since I set repeat to 5. This list would be returned from the repeat function. And every entry here was a timeIt call of the number parameter here, timeIt of number for every single call. So if you just want to execute your code once, you can use the timeIt method. If you want to execute the timeIt method multiple times, you can use the repeat method. Okay, if I go back to our code, I have created here an object of the timer class where I pass in our statement and the import string. Then I, for example, executed here the timer.repeat method, where I set repeat is equal to num runs, which is here just 3. So I will execute 3 times the timeIt method under the hood. So this code here is executed number times. This would just return, for example, 1 second. And this would be 1 run of our repeat parameter here. So this repeat function, as I said before, would now return a list with num runs, time durations, and I will print these, and I will print the mean computation time now to the console if I will execute our program. So if I execute it right now, I would see, okay, 100,000 executions of this vector addition took, for example, 0.568 seconds, 0.552 seconds, 0.586 seconds, for example. So now we would have the times for 3 different executions, and the mean computation time is, for example, 0.569 seconds. So now I would know how much time does our vector addition take. But important, these times here are for executing the addition 100,000 times. If I just want to run it one time, it might be a problem here because it probably just takes, I would guess, 10 microseconds or something like that. And as shorter the time durations are that are needed to execute a Python code, the more unprecise these timings are. So I would see here 2.35 e minus 0.05, that would be 2.35 times 10 to the power of minus 5, for example, which is a pretty small number. So now this printing it out here as seconds isn't that much useful. You could multiply it by, for example, 1 million. Then you would see the times in microseconds. So if you multiply it with 1000, it's a time in milliseconds. If you multiply it with 1 million, it's a time in microseconds, for example. So if you compute it right now, okay, we see it's a list. We can't multiply it by a float value. That's correct. So let me do a little trick for how many t for t in times, and t is multiplied now with 1 million. So I'll do a small list comprehension here, such that we can multiply our values in the list by 1 million. And now we would have the execution time in microseconds. So one vector addition would take 22.8 microseconds, 6.1 microseconds, and 5.8 microseconds. And here the mean computation time would be 11.57 microseconds. I round these values, Okay, if I execute it again, I would see, okay, it's again a little bit different. So as a side note, every execution is a little bit different in the execution time, since I said before, your CPU is just giving every task on your computer some amount of time to be executed or computed on your CPU. And this is always a bit different. So if you execute it 100 times, you will get different values. As a side note here, the first entry takes more time because the import string is executed at the beginning. So import strings executed once, and after that the for loop starts about our code here. So now you would see the times in microseconds. If you want to see it in milliseconds, as I said before, you can multiply with 1000. If you want to see it in nanoseconds, which is most times not really the case in Python, since Python is not the fastest language, you could multiply it with 1 billion, for example. And now you would see the execution times in nanoseconds if you really need this. So this is how you can use the timeIt module to time your code. The important thing here is you have to pass in the code you want to time in these triple quotation mark strings. And if you have any setup or import statements, you have to pass them also to the timer class. Okay, then we will see us in the next video. Bye bye.